So let's talk about this logarithmic function. So we have the exponential function that looks like this. This is y is equal to e to the x for the most part. Let's write a little lower. Now there's this imaginary line running through our graph paper that looks like this. The logarithmic function is the inverse of or the exponential function, and it looks like this. So this is what our logarithmic function looks like. And this is y is equal to log base a of x. Just want to make sure. Now you'll see for this that what's our domain for this graph? For a logarithmic function. And if let's go back up here to the exponential function. Do we remember the domain? It was negative infinity to positive infinity. And the range was from 0 to infinity, if you recall. That's what exponential function. Now, the logarithmic function is the reflection or the inverse of the exponential function. So for logarithmic function, the domain was the range of the original exponential function, and the range is a domain. So the domain for the logarithmic function was what the range was. So this is now 0 to infinity. And if you look at the graph itself, you'll see that's true, because if you follow this graph down here on the left, the x value does not go below 0. So the lowest x value for this graph is getting closer and closer to 0. It never changes. And if you go towards the right, the x value is going up and up. So the domain is that. But if you remember the exponential function, you know the logarithmic function. What's going to be the range for the logarithmic function? It's how high or low it's going, which is the y value, or it's the domain of the exponential function. So negative infinity to positive infinity. So once again, we're just flip-flopping the exponential on a logarithmic function. So if you know the domain and range of the exponent, we flip it around and it becomes the domain and range of the logarithmic function. Now, if you recall, for the logarithmic function, we had a horizontal asymptote. For the, as I say, logarithmic function. For the exponential function, we had a horizontal asymptote. For the logarithmic function, we're going to have a vertical asymptote. Here, and the vertical asymptote is y is equal to 0. So our vertical asymptote. right? So what's going to make this function change? Y is equal to log base A of X. So I'm talking about this briefly. If there's a number attached on the inside of the parentheses, this is a horizontal shift. And if we add something to the whole problem, just like with any function, this is a vertical shift. Now let's talk about common logs. Does anyone know what common logs is? All right, I should have more time, but common logs just mean that we have a base of 10, which is what some of you were, I think, talking about earlier on, right? Now, if we have a base of 10, we normally do not write the base. So we would just write log base log of x. So we know that the base here is 10. It's just an unwritten 10. And we also have natural logs. What is our natural log? Yeah. So natural log is a base of, well, that's equal to e, right? And so this would be the log base e of x. Now, instead of writing the log base e, the shorthand for that is ln. So ln just means that the base was e. So here we go. And these are two. The base could be anything. The base could be 2, 3, 4, 5, whatever we want, right? As long as it's positive. But these are two more common ones, and these are the ones that are actually in your calculator, right? Some of your homework actually has some, silly questions. For example, number 7 in your homework says, find the ln of 0.0517. It's just really a matter of sticking this in your calculator, right? What would the answer be for that? Negative 2.96. And that's rounding to the nearest, to 2 decimal place, or to what we said, the nearest hundreds. Because my MATLAB, by the way, be careful. They always ask you to round to decimal places for problems like this. Now, I want to look at some properties of logs. Oh, here we go. Have you guys seen these rules before? It says if we're multiplying, so the first one is a product rule. If we take the logarithmic of a product, we're just using the ln for now. It doesn't matter which log it is. It's the same thing as finding the individual logs and adding them. And the quotient rule, this is a quotient rule for logs, not for derivatives, right? says we're take the logarithmic of a quotient. It's the same thing as taking the individual logs and subtracting them. Then we have the power rule. For logs, it says we have the log raised to an exponent. We can move the exponent to the front to rewrite the problem and to get rid of the exponent. And you'll see how all this becomes handy later, all these three rules. And rule number 4 is one of the inverse properties of logs. And basically, this is what we're saying in the last problem when I said that my MATLAB got ahead of themselves. Because in essence, you know, the ln and the e cancels out, leaving us with just the exponent. And the reason is because there's a base e here, and whenever these two are the same, the answer is just the exponent. And that's the inverse property of log. Let's see what I have here. Alright, what is some of this stuff good for? I'm going to save this problem until next class, actually. We'll continue this. One of the uses of log is to solve exponential equation. And they come in many shapes and form. For example, like this word problem here, but we're going to say the word problem for now. We're just going to go to a regular equation and then look at the word problem. For example, number 8 in my MATLAB says, solve e to the x, which is an exponential equation, is equal to 14. So we're trying to find x, or x. So how do we do that? Anyone? We're actually going to make use of the last property, the inverse property, here. And it's the same thing we did in that problem on the exponential equation. We're going to take the ln of both sides. There you go. And on the left side, what's going to happen? What do we end up with on the left side? So Carlo, what's the ln of e to the x? Done, just x, right? So we go back to this rule, the ln will cancel, these basically cancel each other out, leaving us x is equal to ln of 14. And that's our answer. It says round to 4 decimal place. So I know we didn't say that, but let's round to 4 decimal place, Samir. So what is that?